Hello everyone, welcome to my YouTube channel. Today we are going to solve the today's problem of the day of Geeks for Geeks. So the question name is sum of XOR of all pairs. Question says that we are given an integer array ARR of size n. Compute the sum of the bitwise XOR for all distinct pair of elements. That is, consider every pair of the indices ij such that I is less than j and greater than equal to 0 and j is less than n, and calculate the total sum of ARR of I XOR with ARR of j or all such pairs. Okay, the question is simple, that we have given an array, and for every two pairs ij where I is less than j, we have to perform XOR operation of their elements, and we have to calculate the sum of their XORs. Okay, so in this example 735 we have performed XOR 7 with 3, 7 with 5, 3 with 5, then add up all these numbers, then we will get the output 12. In the second example we have 5, 9, 6, 7, and we have to perform XOR with 5 with 9, 5 with 7, 5 with 6, and 9 with 7, 9 with 6, and 7 with 6. Then after that we will add up all the numbers, getting we will 47, and if there is no other number we have 0. So in this way we perform one of the brute force approach is that simple, that for we have to calculate all the pairs, then we will get the XOR, and then that XOR would be calculated by the complexity of n square. The brute force cannot work here because the constraint is given 10 to the power 5. That will give us the time complexity n square, and we will got the TLE, that is time limit exceed. So for that we have to think about the new solution, that is less than n square. So we will going to write the bitwise operation, that is a trick for getting this answer. So the trick is we can think like bit by bit. So for each position 0 to 31, for each position count how many number of we have bit 1, and count how many number have bit 0. So when we get the bits of 1s and 0, we will multiply that count of bit 1s and count of bit 0s. Okay, then multiply the left shift of bit. Okay, so in this way we can get it by linear time complexity, and that is big O of n. And I am going to write the code for same, that is the most optimized code, like n equal to len of ARR, and after that the total sum, or we have answer equal to 0, that would be accumulated for every XOR of pairs, and we will have for loop for bit in range 32. So for 32 bit operations we have to make a while loop. For every bit we will take a count of 1, how many number of ones, that is count 1 equal to 0 initially, and then for number in ARR, if number right shift with bit, and we will check whether it is 1 or not. So for that I am going to end operation with 1, that would give us count of 1. So we'll increment count 1 plus equal to 1, and we will, after calculating the count 1, we can calculate the count 0 by subtracting it with count 1. So count 0 would be n minus count 1, and after getting count 1 and count 0 we will calculate our answer. So the answer, though these the contribution from answer would be the multiplication of count 1 and count 0, and that would be multiplied with 1 left shift of bit. For every bit we will go to left shift, and then perform the check the contribution for each number. Then we will return the final answer. Let's try to run this, and then we are going to submit that. Okay, something is error, let's check it. Oh, so in line number 5 we have a bit in range. Okay, now try to submit that again. yeah, we have passed it successfully. Thank you for watching. Hope you understood the logic, and it is very simple, and we are using big of and linear approach. So thank you for watching. Hope you enjoyed that. Thank you.